Thank you guys for coming to the first 2017 Tuscaloosa Web Bankers.
Yeah, cheers.
Gentlemen.
Thank you.
So I guess I'm going to give you guys kind of like a short introduction to GraphQL. To start, I guess all you guys know that I'm Wes Eldridge. I own a company, which we're here today, that builds brewery management software, and then I also do some contracting work with Ryan at Randall Riley and Product Development Group. So about a year or so ago, we started looking into using GraphQL to kind of as an alternative solution to our current data layer. And so some of our motivations around it is to start using it. It is. It wouldn't go off. It's Leo, so.
No.
Was it Leo?
No, it's the other radio voice, James Fan.
Oh. Looking at that weather details.
I launched an app to find the link to the live stream, and the video I was watching this morning continued to play.
It wasn't important.
True story. And so, yeah, we don't really have terribly many clients, but we are already kind of reaching some scaling problems with our data layer as it stood at the beginning of the year. And then we also have some other secondary systems that help us run our software. And so we didn't actually have a really clean way to integrate with those. And we're kind of, due to the technology that we have up until this point, we are kind of limited for MongoDB as our backend. And so this kind of set us on the road to exploring GraphQL and working with Meteor to do some other stuff with a data product that they're building right now. So what exactly is GraphQL? And I've stole this directly from their website. It's a query language for APIs. And so you can kind of almost think of it as like MySQL or some of the other database query languages, but it's specifically for your application. So I think the guys from Apollo in one of their blog posts showed a really great diagram of actually kind of an interesting way of thinking about GraphQL. And that's this one. And so over on the REST side, you kind of have your normal paradigm of how your client will talk to all of your different, I guess, in many cases, microservices or different APIs, and you kind of have different backends for all of those. And so GraphQL kind of consolidates all of those down into one, and it allows you to keep your microservice backend or any other existing backend that you have, and kind of allows you to unify it and then present one API layer to your client for it to consume. And so one of the great things about this is it allows you to versionlessly evolve your API. So you no longer have to worry about every time you add a field or do a schema change or add a new piece of data to your API for you to have to bring a new version. And some of the tooling around GraphQL is really great. You can do some monitoring of your queries. And so as you get ready to deprecate a particular piece of data out of your API, you actually have visibility into the usage of it and where it's coming from. And so it kind of gives you an idea of kind of like a roadmap or like a sunset to allow you to deprecate things without having to version. It also allows you to, with the traditional REST, you often have version 1's on one code base, version 2's on the next, and they do share some data or some code between the two, but it's not necessarily always, it doesn't necessarily always happen that way. A lot of times when you evolve an API, you use that as an opportunity to use different technologies, or so you end up having a really messy backend. And so it also is a really readable query language. And so you're able to query, as you can tell from right here, this is what a normal query looks like from the client. And when you query, you get your data back in the same way that you queried it. And so in this case, we're trying to find all of the brews that have been completed, and we want their status their batch size, and the recipe and their name. And so we get that data back exactly the way that we queried it. It's also one of the great things that it's self-documenting, and so no longer do you have to worry about writing doc blocks over every piece to be able to automate your documentation. When we get done with this little talk, I can kind of show you how some of this works, but essentially your front end always has the ability to see what your entire schema and data is at all times. That makes it really convenient for like front-end developers to be able to jump into a schema and essentially just walk through it to see what different pieces of data are available to them. And then you kind of see this is the first schema diagram. I think we generated this somewhere, I think like in April maybe. But this is the initial version of our schema as we started to build it out. And then you can build these diagrams just by running a command line. And so you can kind of see there's an entry point, which we do like authentication to make sure the client is authenticated. Then you can kind of see how the schema grows and where all the interactions are at. I tried to generate another one, and I'm not sure if it would even fit on this page anymore. But. And then it has a huge support for server-side languages. You know, it's just recently come out of like beta preview, and it's actually now a stable piece of technology. And so during that beta period, there was a huge explosion of clients, server clients, to be able to broadcast that schema. And so JavaScript and Python by far have the best implementation of it. Like Python has one called Graphene, and I guess one of our contractors, he actually uses that in one of his other jobs to essentially expose a GraphQL endpoint. I played some with the PHP, and I haven't really played with any other ones, but I know they do exist. And then you're starting to see more of the client libraries come online. And so one of the big clients, and this is actually a product from Meteor, which is what our technology is built on, called Apollo, and they have a client for JavaScript, so like your normal web front end, and they also have one for iOS that allows you to work with within Swift and Objective-C. And there's some other ones, Relay and Loca. Haven't really used much of those at all. And so I guess we just kind of go into demos and questions. I don't know what necessarily if you guys have anything. I may have to change the screen resolution because I absolutely can't see anything on this thing. My mouse is so tiny. What's the built-in?
Should be an option for like scale.
I get a 1080p. How does that look? Yay!
Go back to slide. So can you talk a little bit more about, I guess, client? So these client libraries, Apollo. So what that allows, how does Apollo work with GraphQL and services? So it works with server-side stuff like JavaScript and PHP and all that.
Yeah. So the client side, so especially like in Apollo and Relay, I can speak a little bit more about those than I can in Loca, but they essentially give you a mechanism for like a client-side cache, like a client-side database essentially, and they do some optimizations, whether it be like optimistic UI. We can actually implement optimistic UI. We're actually doing it, but it also provides a client-side cache. So if you are running like a single-page application, if the data already exists on the client, there's no reason you should query for it again, and so it will actually present that data that it already has stored locally to it. And so Relay and Apollo both do both of those. And so one of these great tools that we use all the time is this, and we're actually using the standalone version of it, but you can boot it up in your web browser as well. It's called Graphene or Graphical, and it allows you to essentially explore your API outside of your application that you're building. So some of those self-documenting things that I was talking about earlier, Graphical actually provides that for you. So you can come over here and jump into the document explorer. And so it's broken up into queries. So that's getting your data, and then there's mutations, which changes your data. And then one of the reasons that we use Apollo for the server and the client is that it provides a subscription layer. And so your data can be reactive. So when it changes, when a client makes a change to it, all the other clients reflect those changes. So you can jump into the root query, and we do all of our stuff through this current user, like our authentication. And then the big piece where most of our APIs is exposed is to this company. So you can come in and see everything that our company object provides. And so, you know, we have inventory, equipment, orders, a couple of different type of brews, suppliers, recipes, some comments, finished goods, which is a really neat thing that we just recently built, and then all of the data specific to a company, like they run a tap room, phone number, EIN stuff. And so we can jump down into, we'll jump down into finished goods. And so you can kind of see what all of the data looks like for the finished good. And so you can always guarantee that your front-end developers know what they currently have available to them. And they also only get the data back that they request. So a lot of times when you do like traditional REST request, or like we run a pub sub on some of our data, you get back the data that the server allows you to have, whether they restrict that or it's completely wide open. And so a lot of times you'll have too much data on the client, and so this guarantees that you only have the data that you want. So like in this particular case, it does like some autofill stuff for you, so we can get the updated date. So these are all the fields that are available to the client. So I don't know any other good ones right off the top of my head, but you can hit play and it'll update it for you. And it will also do, so this is a static object, and so we can change it to where it is something to where there are a bunch of brews, and we can do, what did we do earlier? Did we have a bunch of planned ones? We have one planned, and so we can pass this in as an object or as an array as well. And we can get brew house completed. Yeah, and so it, maybe it's just, I don't know what it is.
Yeah, there you go.
And so now that we're requesting more than one particular piece of data, it still returns it. So all of these fields match perfectly over here, but it just returns it back as an array of data. It's kind of cool. And they also do some really interesting things. There's some libraries for your server as well. One of the great things about this is, let me pull up kind of server stuff. So on the server, you don't traditionally get to see this in most GraphQL talks, but the server allows you to integrate into any database that you want, to any existing REST API, and a variety of other type of data stores. And so it allows you to do compositions of things across different data layers. So you can have, so like this request that I have right here, you could potentially be getting data from MySQL, Mongo, and an existing REST API, and it will return all of that data in one request to you.
Can you go back to the slide that is REST versus GraphQL?
Sure.
So, to his point, the right-hand side, the SQL database or MongoDB, S3, but also there could be a REST API as well. So, and GraphQL can marry all that together.
Yeah, based off of keys. And so the way that they do that is through what they call resolvers. And so we kind of have it laid out on our server. So we keep all of our mutations for a particular collection, resolvers and schemas kind of local to each other. So you can come in, this is what a schema looks like. And so you can define different types. You can define custom types, and then you can also define inputs, which you use in your mutations. And then in this particular case, because we're using Mongo, we don't have to write resolvers for everything because it will automatically resolve based off of the field key or the document keys that are fields that are already there. But there are some custom ones like this BB number. It's kind of like our representation of kind of like, it's almost like a scalar quantity with like some type of unit, so like gallons or ounces or something kept on it. And then so you can come in here in these resolvers, and this is where kind of all the hookup magic happens. And so let me see one where we have data. So yeah, so here's the finished good by selector. And so this allows you to pass in a company ID, a type, and a recipe. And so we can build our query based off of that, and it will return it. And it knows that we're going to return a finished good. And so if you come back over here, it knows that it's going to have these fields available. So you can actually take away some of these fields in the schema, and it won't return it to the client. So you can kind of limit what you give to the client based off of the schema that you write for it. And so if you were to do like a REST API, so like for some reason, like let's say on finished good, like our created at date was kept, you know, in Google or something, you could do, I don't remember what the HTTP is. So you would be able to do an HTTP request from in here. I don't actually know how their API for that works, but you'd be able to do it and return this, and it would be in that data for you. Yeah. So yeah, that's kind of like a little short overview of what GraphQL is and kind of how it works. And
So one of your slides was the schema, and you started with I think the session or the user login or something like that. Where is it that you actually define schema? Because it seems like there's certain methods that you were just looking at where schema is being defined.
so yeah, so just because of the size of this project, like we spread it out so they're to each other. So we have this Apollo folder, and so you can come in here to these type definitions, and so this is like where all the root queries live. We have the schema here. So we're just importing all of our schema from the individual files, and we use this thing called GraphQL tools that makes those schemas executable. And we just import them all right here.
Yeah, so can you show us one of the objects schema?
One of the schemas?
Yeah.
You were looking at one right here. This is what it is.
Okay.
Yeah. So you can actually build this from like traditional like JavaScript like objects and like pass in, I guess JavaScript functions and methods, and pass in an object that will build your schema for you. It's just not as easily read as doing this, and so we chose to kind of write it out as a traditional schema to make it a little bit more comprehensible.
And if you choose to add another column to your traditional, database, do you start by modifying the database and then go into this file and add the column?
Yeah, so it's like if we were to add something to finished goods called like, what's a field name?
Value. Like for I don't know.
So like if we do a value, you could do like float, and that would then be on the, and we'll actually even do that. So let's hop in here to the resolver, and yeah, but you can just see kind of how it works. So I've never actually done this, so I don't know if it will work, but we're going to try it anyway.
So that sounds like it's gonna be a static value the whole time, and the database is never gonna be talked to.
No, but this would kind of be how,
Yes.
so like if this field existed on your database, it would automatically map that for you. But I don't have that there,
Yes.
so it's going to take just a second to rebuild. Value.
Fancy.
It didn't actually return it the way that it was. Yeah,
Because it's a float, not a string.
you're probably 100% correct. So quick. Yeah, there you go. So it actually does do like some validation for you. So if it's not the correct type,
That's right.
it doesn't return it for you. So yeah, this is some really cool technology coming out of Facebook. A lot of people think that it will end up replacing the traditional REST client. And you actually are making HTTP like standard REST request to actually get this data. It's just kind of like an abstraction layer that sits on top of it that makes it a little bit nicer to play with. Any other questions or anything?
What API stands for?
So what?
What API
Oh,
stands
API.
for? API, yes.
It stands for Application Program Interface. It just allows two applications to talk to each other. That's just a fancy way of saying that. Or
Yeah.
essentially, the gateway that two applications can talk to each other is not like it's set in place. It's just like, hey, you can talk to me through this telephone, and this other one I use a cell phone. Kind of have to write the interface for them to be able to talk, but it's just allows you to be able to talk to another application. So yeah, GraphQL.
And so without Apollo, it's not reactive at all?
So Facebook is also working on this, and so we chose to use Apollo because they do subscriptions, and Pro runs off of pub sub, and so you subscribe to a set of data, and anytime that data changes, we push it to the client, and so you don't actually have to do polling to get updated data on the client. So we don't need that in every situation, but it's really nice to have it, like when you're having like a feature that is collaborative or multiple people will be using that at the same time. And so the Apollo server essentially will create like a WebSocket that then will talk to the Apollo client. They can push data through. And so they give you the option of defining how the data is merged on the client once it's pushed. And they kind of give you some other neat things. But this is the Apollo. We were supposed to demo this, but we were really busy and we didn't actually get to do it. At least once they had it built. But this is a kind of like New Relic, but specifically for GraphQL. And so it gives you different performance characteristics. So it shows you how you can like optimize your API over the long time. Who's requesting, how long it takes to make a request.
So with respect to like you talk about your data being pub sub.
Yeah.
Is that an all or none decision?
To go with the data.
With respect to polling versus pushing.
So it's done through a WebSocket. So the implementation of how the server knows about the changes in the data can be done differently. So our implementation can pull the database however frequently. But the reason why Meteor is tied to Mongo is that you is its op logs, like the bin file for MySQL, and it just tells it to see operational changes. And so that allows you to, there's a couple of other ways to do it. So you can actually, there's a package that had just come out that allows you to do your pub sub through like a Redis instance, but it's actually done programmatically. And so it only knows about changes to data that has come through the existing API, whereas the way that they currently have it, any other application can make modifications to that Mongo instance. And because it's telling that op log, it knows that some data has changed. It may not have been changed from the original application, but it still knows about it and push those changes to the client.
Yeah, so I guess I was wondering, is the entire set of data that
But for us right now,
that your program, that your application, is it all going to be either push or pull, or can you have a mix?
so that's why we kind of did Apollo. So that was one of the big reasons why we wanted to change to Apollo, because not everything needed to be reactive, and everything in Meteor by default is reactive, and it's really hard to change that.
Okay.
And so, we're kind of slowly, like incrementally adopting GraphQL. And so, we're playing with some of the subscriptions because it's kind of a new technology for GraphQL and a couple of low risk areas. But everywhere else that uses Apollo, like our GraphQL, the data is not reactive at all. There's a couple places, like I was showing you earlier, like when the equipment, how it was like changing, like when it would change on one client, it will change immediately on another. That was done through like the publication and subscription model.
Does Apollo have any type of error handling such that it's aware that the client did not receive a pushed set of data?
We haven't had any trouble with that.
Okay.
Right now, like one of the only places that we're kind of running our subscription GraphQL is on this, so you can actually see.
When one screen updates, the other one should. Yeah, nice. And it's almost, it seems seamless and instantaneous.
Yeah. There will be a little bit more latency than you would have on the other pub sub that we have. But I don't think we've seen any and like if your data can be to another client within a second or two, or maybe even 5 seconds, like unless it's like something super mission critical where it like shuts down something if something happens, like that's something that's tolerable.
Is there a much difference between Apollo and PHP?
PHP. There's not actually an Apollo client for PHP, and so if you could just kind of, we can go to
Or depend on the client?
So there is the Apollo client, and it will work on like any web app. So if you wanted to use Apollo to manage your data on the front end of your so like once if PHP, a person makes a request, we build that page on the server, and then we send that page out to the user. So once it's on the user, you can use Apollo to communicate back to your server and bring data back in. But if you wanted to use Apollo server on PHP, you can. There are, that's code. I don't actually know where. Learn, community. I'm betting it's community. It's not community. Oh well, you can do like if you wanted like a PHP GraphQL server, they make them. This is the big one. And so the work that I do with Ryan and Randall, like everything we do is PHP, and so I hope to be able to do an experiment with this soon. But you can essentially use, so like we use something called Laravel as like our PHP framework. You can kind of think of it like WordPress, I guess. But we can essentially use all of our existing representation of what our data will look like and essentially wrap that in a GraphQL data type, and it will build your schema for you. So we have, and like, you know, there's a bunch of really cool tools out there that will do schema building for you. Lazy and sublime it. So to ensure that we have what would be the best way to say that? So Mongo doesn't require you to have a schema. So like a MySQL, like where you have like, it's like essentially like an Excel table. This is not like this. Like they call them, it's a collection of documents, and they can be however you want them to be. That there has to be there doesn't have to be any consistency between documents in the collection. So we enforce a schema on top of it. And so we could really, if we wanted to, use some tools to automatically generate our GraphQL schema based off of the schema that we've already defined. But, you know, to each his own. I hope to get away from this at some point.
Well, thank you, Wes. I had something I wanted to share. So I'm if you just minimize everything, I'm gonna sit up there and I'm gonna paraphrase from an article that I came across.
Yeah.
So at the turn from 2016 to 2017, there was a leap second. And a leap second is to adjust time between what we're used to having, 3,600 seconds per hour and 86,400 seconds per day. It doesn't exactly equate to like being even with the solar, like the Earth traveling around the sun, and the fact that the sphere of the globe of the Earth is not exactly a sphere. So there's not exact science. So
a huge amount of
it is. So, they end up having to use leap days. So that adjusts it a whole day at a time, but they end up overshooting and they end up getting a little off. They find their way back. So a leap. So a leap second is what is necessary to make small adjustments. And there was one, maybe June, there was also one that was supposed to happen at midnight and it did happen, midnight on December 30th, December 31st, going into New Year's Day. So Google had a dilemma of how do we address a leap second when we have a lot of data that needs to happen in chronological order. And you can't push out an update to all of your servers saying, update, go forward a second, update, go forward a second, update, go forward a second, and hope that everyone heard the request and do it all at once. So they thought about how to do this. And there's a system that servers rely on called Network Time Protocol, NTP. NTP is a protocol that servers can ask another authority server and say, what time is it? Now, there's a couple things that go into an NTP request. How long did the request take to go from the client to the server and from the server to the client? So that's your latency. And then what was the answer that I got? And the client will take the answer it gets and of the two things, how long did the round trip take, and the answer it gets back, and adjust and make and set its own times on the system such that it knows, so that it's in sync. So typically in a data center, you're going to have an NTP that is responsible for keeping everything in sync. So they had an idea to not adjust time all at once, but to adjust time over time.
So
Instead
it's
of
like-
doing a
so not doing-
second, instead of doing a leap second, they were going to do a leap smear, SMEAR. Over the course of a window of time, they would increase the time fractions of a second, such that between when they started and when they ended, they would have advanced one whole second. But they basically had their, because here's the problem. If you were to go through all the code and say, how well would this code respond to a 1 whole second change of time, it may cause catastrophe. It may cause your sent mail to get sent twice or never be sent at all. So they were using their Stratum level 2 NTP servers, so high level but super precise, to actually tell a lie and use a formula to say that as we go from here to here, from the beginning to the end of the window of time in which we want to adjust, slowly but surely we will add a whole second. So the NTP servers were adjusted, and there was no Y2K in 2017 because of a leap second. But they actually did an experiment. They performed 2 smears, one going backwards because it's possible, but it's never been necessary to have a leap second in reverse. It's possible that you have to make a micro adjustment in the other direction. And they also did a positive one. They tested 10,000 servers at once. They had previously added monitoring so they could plot the skew between atomic time and the time they wanted to get to, allowing them to consistently evaluate the performance of their time infrastructure. And it's like amazing that there's that level of people paying attention to this.
I love how their experiments 10,000 servers.
Right. So they were excited to see the monitoring showing clocks of those servers' clocks were tracking what they had predicted, and they were continuing to serve users' requests without errors because they were still in order. So they did their successful test, and then they reconfigured their servers with the details of the actual leap second ready for New Year's Eve. And when they would actually automatically activate the smear for all the production machines without any further human intervention required, except for the possibility of someone needing to press the big red button to say, stop, we're not going to do this. So it's really cool. There's a blog post that I'm paraphrasing from on googleblog.blogspot.com. I don't know why they're still run on Blogspot. I know they own it, but it's Time, Technology, and Leaping Seconds. Pretty cool read.
Yeah, like I was thinking of like how to do that because they have hundreds of thousands, if not millions, of servers.
Yes, so there's a formula here that is, they actually have a, here's the science part of it. Usually when a leap second is almost due, the NTP servers say a server must indicate to its clients that that there's a leap second coming, that they set a value known as the leap indicator. This indicates that the last minute of the day will either have 61 seconds or 59 seconds, such that you can support the forward or backward movement. Rather than doing this, they applied a patch to their NTP server software to not set the LI flag, the leap indicator flag. Instead, they wanted to tell a small lie about the time and modulate the lie over a time window known as W leading up to midnight. So, and they have a formula, and it's not worth me trying to do parentheses and verbalize that. But what they did was make sure that this lie we were telling our servers about time wouldn't trigger any undesirable effects, and such as causing them to suspect the time servers to be wrong. Because if the client suspected the time server was giving them bad data, it would ignore it. which is also problematic. It also made sure the updates were sufficiently small so that software running on the servers would, anybody who was doing any type of like synchronization wouldn't lose locks on or there wouldn't be any abandoned operations such because all of a sudden time is not what you expected it. But also, this is the biggest piece. It meant that the software didn't necessarily have to be aware or resilient to the leap second. They didn't have to touch any of their code. And that was their biggest part they were trying to avoid. How do we avoid touching our whole code base to prevent a problem? So really cool. Time, technology, and leaping seconds.
It's great.
Of course, it's doable.
Yeah, I know. Well, they're like, they're one of the only companies who have to deal with that type of scaling issue. They have Amazon, Facebook.
All right, well, I'm going to sign us out.